We're good.
Okay, everybody, we're going to get started here. First of all, I'd like to welcome you to our webinar on PS0, the pore strip alternative. And I hope everybody's doing well and staying healthy during this interesting time we're living in right now. And I'm sure this isn't the first webinar you've had over the last couple of months or Zoom type meeting. So we're going to try to roll through things pretty quickly, and we're going to give you an overview of our product, how we developed it, why we developed it, how it's compared to some other things on the market, and then we're going to tell you a little bit about at the end how we've changed it since we've had some installs. And then we're going to leave a lot of time. We're trying to leave a lot of time at the very end for some Q&A, because we do get a lot of questions. So please utilize the Q&A part of the Zoom webinar. And as we're going along here, if there's any portion during the webinar you have a question, just type it in, and we'll start to look at those from kind of the first ones to the end, and hopefully we can get through a lot of them. But today you're going to be hearing from my dad, Gordon Raikstedt, who is our president and the developer of PS0. And also Jason Raikstedt, my older brother, who some of you may have seen a few years ago in ENR magazine. He was one of the top 25 newsmakers for some work he was doing on failures in carbon grid reinforced precast double T's. And he's also been involved in some recent articles in Concrete International. So, and then of course me, you'll hear from me. I'm gonna be talking as well and kind of being being the moderator of our process here. So, all right, without further ado, let's just get started.
There you go. Yeah, you gotta get it going. Yep. Good.
No. Okay. Sorry about that. So basically, we are first and foremost structural engineers. My father started this company over 40 years ago, and we developed PS0 from our structural engineering experience and expertise. We've developed products over the years and methods on fixing things. And we've also been, we don't do this anymore, but we've actually been in the contracting world where we actually used our products and our methods to primarily repair post-tension concrete parking ramps. So I'm actually going to turn this over now to my father, who's going to talk a little bit about our history and the things that he's been involved in.
There you go.
Hello, everyone. I'm really excited to share with you some of our experience and part of my journey. And now as our journey continues with two of my three sons in the business, the other one's a pro golfer if you're interested in lessons or whatever. But we have over 40 years since I started doing this after being president of a new precast operation that I was experienced, but I've had a lot of experience in concrete and over the years with PT, hotel towers, office buildings, parking garages, and repairing parking garages. And we went on quite a ride from the early 90s with Lyle Berman building grand casinos and being involved in projects like the Stratosphere. And so this has been a huge and interesting ride in structural engineering. And you can see with two sons in the business, I really like this, and I think it's a great profession. You know, and in addition to that, because of our precast background, we've got a precast specialty group, and now we have some steel connection design. And I've always, with the PhD stuff, always done some forensic design, especially earlier in my career while we were trying to build this business. So we've been involved in developing things. This first encapsulated PT anchorage system that we put together, it was the Model 84 before people were even thinking about it. But we had a River Center garage in town here that's like 1,600 cars, and it was an early button-headed system, and it really needed to be replaced. Even though it looked really good, In those days, there was very little mild steel, lots of PT, like a zero tension design. So we got involved with that, and I became a contractor eventually and did that work. Actually, we finished those repairs when the Wild opened in 2000. And in addition, then we found some non-destructive ways. I like to be a computer programmer as well, to find, to high speed, find broken tendons. And that became, and then we did the PT repairs of many of those, and as a specialty contractor. And so we've been involved in just all kinds of aspects of structural engineering. Now, today, we're really back talking about pour strips. And these have been a challenge for me in my career. The challenge only comes from contractors because of the safety issues, but more because of schedule issues. And you've got these big gaps in your building, and crossing these gaps was just a real challenge. So the challenge always was, how quickly can we pour it back? How quickly can we get a floor all the way across? And so these, leave outs between two slabs are absolutely necessary if you want to have a reasonably crack-free floor system. And they're typically anywhere from 4 to 8 feet wide and open for 28 to 120 days, maybe. I think some contractors like Arup or designers like Arup have pushed it out to 6 months, maybe because they can. And the reason for the pour strip, of course, is to get continuity of the slab. You need the shear, you need the flexure, and then for the diaphragm portion of the slab, you need the continuity of the cord steel. And since all of these things, what should I say? The concrete, our whole business is about stiffness. And the concrete wants to pull toward the stiff elements, usually your vertical shear walls. And why do we need them? Well, I think we kind of all know volume changes. The ones that are particularly sensitive to that are PT slabs, where you get the elastic compression issues of shrinkage, in addition to shrinkage itself of the concrete and creep that happens. And so we'll show you some stuff where we're even going into mild reinforced joist systems and that with pour strips that we solve this problem for them. These things are, typically 200 feet long for a lot of the hotels we've done on pieces of the pour, and the gaps are 3/8 to, I haven't seen very much up in the 3/4 range, but under unique situations, you can get there. And if that shortening isn't allowed, there's a couple of things that happen, and you should be aware of that. One is answering to an owner or an architect about all the cracks in your system. And don't use the answer that, well, that's typical, because it isn't. And the other one that I don't know that a lot of engineers pay a lot of attention to, but if you got 2 anchors or shear walls at the end of your slab on a 300-400 foot long slab, those forces of the PT often are transferred directly into those shear walls. And the PT forces that they're supposed to be in the slab, we put in typically, 150 to 200 PSI in a typical slab. And then the cracking, the cracking moment, the cracking tension, is up in the range of, say, 500-600 PSI or something. So if that's in the slab, it takes you're having 700 PSI somewhere to crack those slabs if you have cracks in your slab. Well, if you have those slabs, it's like, where did those PT forces go? What happened? Well, that's what happens in some of these things, okay? And all concrete that I know of is affected by volume change. And this is something we really have to pay attention to. Really, it's the serviceability side is what we have to pay attention to there. We got introduced, this is near our Gulfport office. We got introduced to this project, it was in the early 2000s, because it was scheduled to open, the Hard Rock at Biloxi was scheduled to open on the day Katrina hit in 2005. And it was a terrible storm. And it did a lot of damage to we had floating casinos. Oh my gosh. We had stuff on Highway 90 It was a real war zone disaster. And by about 2014 or so, the Hard Rock was doing well enough to actually be able to build a second hotel tower, and this was it. And the general contractor that we had a long-standing relationship with was almost 6 months behind schedule. They had 120 inches of rain without an unnamed storm. Oh, it was a disaster, and they came to us looking for answers, and we tend to be problem solvers for our contractors. And from a lot of our contract, they'll say we're the best problem solvers we know. Well, they had a big schedule. I'll let Jay, my older son here, get into this. He was very involved in some of this stuff at the time, and let him explain what we did and what we were presented with.
So the contractor, being behind schedule like this, he was looking for any answers he can to pick up time. Okay. And we were on the, 10th or 11th floor of this tower. And so that all of our foundations were in, our shear walls were in, and they submitted, it happened to be a Helfand lockable dowel. They're all similar, but this one was particularly a Helfand lockable dowel. And what we found is, it met some local shear requirements, but it didn't meet the local moment requirement. And it didn't meet the diaphragm continuity requirement. And so I get asked a lot of time from contractors, architects, owners, kind of why we need pour strips. Well, this was that tower. And right here is our pour strip. It's kind of in the middle, right here. And then if you see the two circles on the ends, that's our stiff elements. And this is kind of a typical efficient design for a lot of what we do in PT design. And if you see the arrows, that's where our slab are. We always want to shrink towards the stiff stuff. And without having that pour strip, you're going to get the cracking throughout that slab. And so again, we got to deal with the PT compression, the shrinkage, and the creep. Oh, there you go. So I was able to locate our original research on the lockable dowel. And this is what it was. And it met the local condition for shear, but we could have done that, we told them, with a simple shear key. We can meet the same requirements of that whole system with simple shear keys. What we needed, though, was to meet the tension requirements or the moment requirements and to have the continuity. And so, but we did tell them, we don't like to say no. We always like to find answers for what the contractors bring us. We did tell them we could use it, but we'd have to go back and install new stiff elements like shear walls all the way up to, because it basically breaks this building in two. It acts more like an expansion joint for kind of load transfer and tension. And the architects, I know, were not going to be happy with extra shear walls, and I know the contractor at the time did not want to add extra shear walls, because then you hit the hundreds of $1,000s. And the other thing, just basically on some, what we found is a lot of folks don't really realize, but the epoxies itself. So what this system uses is an epoxy filler right through here to lock this thing together. In most of the buildings we do, we have a fire rating requirement of at least 1 hour, and a lot of times 2 hours, and around 200 degrees Fahrenheit, the epoxies go into what they call glass transition, or it gets soft, and the systems, you can't get a fire rating with epoxy systems like this.
It is combustible.
And if you ever want to do an experiment, we have a lab in our basement. Take some epoxy that's dry, put it on a plier, put a lighter under it. It will start on fire. And the other thing is this is not code approved. And it didn't work for our design. And so getting into the research more, we do a lot of stuff with the ACI. My brother Jared's on the new 319 committee. The new president of the ACI is a close friend of ours. And what they basically found is the same thing we did. And everybody agreed it's just not a code permitted splice. And so now, well, let's look at what are the code committed or code permitted splices. And so I still kind of work in the 318, 11, and 8. It's a little simpler, but it's in the 14, and then we're reviewing the 19 lately, and everything's in there. But there's 3 methods that are allowed to develop strength in our rebar. And one of them is our lap splice, that's what a pore strip is. It's just a lap splice where you have to have bars long enough to develop that strength. The others are a mechanical splice and a welded splice. And so the PS0 is a mechanical splice. And so, it's approved per the ACI or the code, and we have the ICC testing. And so here is the coupler as it is today. It's a simple rebar coupler, mechanical based, that is grouted, and we had to make it a little longer to deal with the volume change. That requires no redesign. So what we found is it's a great VE that can be added anytime in a project. If you're on halfway up, we can add it. If you're on the top floor, we can add it. And because we still create all that continuity of the engineering requirements, and we get the safer construction. We don't have any fall protection required. You can use the whole slab. And again, it's ICC approved. So now, what's the PS0? If we look at traditional pore strips, the PS0, relies on a mechanical coupling, whereas the traditional pore strip is just a lap splice. We have no leave out, whereas the traditional pore strip has a leave out. And one of the big benefits that our forming contractors have found is they don't need to leave their formwork up for the pore strip. It gets done in 2 pores, or 1 in pore 2. And there is no formwork required, so that's gone. And all of our reshoring or any shoring that's required is the same as what the original EOR designed. So there's no changes to any reshoring. And we provide, all the shear, and so does the lap split or traditional pore strip. And we provide the diaphragm, same as the pore strip. They're both ACI approved. They're both can achieve the fire ratings. And the PS0 does it without needing fall protection and the use of the whole slab. Now, when we look at the PS0 compared to the lockable dowels, they both meet the local shear requirement. The PS0 meets the local moment requirement, and the lockable dowel just didn't from our original research. And the PS0, again, it meets the diaphragm continuity. And, we have 0 redesign with our system. It's a continuation of your structure for global structural requirements. And we use a cementitious grout, and not epoxies. Epoxies have actually been banned. Epoxy, epoxy anchors have been banned in a couple cities around the country just due to pullout. It creates a sudden brittle. The failure is it's a pullout. And ours is ICC approved. The lockable dowel is not approved, and we do not need the additional confinement steel per the ACI. So if you look at even the details from the Halpin or from the lockable dowel systems, that confinement steel that they kind of show, if you look at it, our opinion was it wasn't actually confined, even if you wanted to use that system. And so here is the new coupler, okay? And it's a simple threaded on one end, and that is pore 1. And then there'd be a bulkhead right here, and you just pour that with the grout tubes in, and then you insert the rebar into pore 2, pour the slab, and you're done. You can come back and grout it whenever you want after the EOR specifications. And so you can look it up. Here's our ICC approval and patent. We went through all the testing, and one of the things we do when we develop new products is we always file patents. But typically we file patents on both the product and the actual method of coupling rebar, or on this one, we filed a coupling rebar through the pour strips. And so we have the method and the couplers. The grouted coupler has been the choice so far by contractors just due to cost on what we found to manufacture the bolted coupler. Now I'm going to turn it over to my brother. He's going to walk you through some case studies of the first few installations.
Hello again. I noticed that someone raised their hand, and we'd love to take questions by hand raising maybe at the end, but if you do have that question, please put it in the Q&A spot on the webinar, and we're going to try to address as many questions as possible at the end of this. So now that you've learned about our company a bit, the background of development, and what the PS0 can do, I just want to walk through a couple case studies and show you how it was actually done in real life here. So this project in particular, we got contacted by a local concrete supplier, and they were getting a ton of pressure on them to close up the pour strip at the podium level. So on the right-hand side of this picture, there's a wood frame structure that sits on a few levels of post-tension concrete below. So this was late in the game. We met with these guys, and 2 weeks later, we installed our couplers. So, and the general contractor saw the value in this and the time savings. So they actually, there was a little bit of an upcharge there, but they actually, said, hey, for a couple $1,000s, this is going to save us a bunch of time. So that's how this project got going. And here's a layout from Cisco, so of the PT. So unfortunately, this thing was already going, and the green portion on the left was the PT that was already on site. And the little red chunk in the middle is the original pour strip. What we typically like to do is to close the pour strip gap evenly on both sides. So if it's a 4 foot wide gap, we like to close it 2 foot and 2 foot and just extend the PT a little bit through there. And because then that keeps the slabs, basically, there's really no additional PT that the engineer really needs. Here, because of the construction sequence and where everything was going, we couldn't do anything on the green side, but on the blue side, we were able to, make those PT cables longer and close the gap. So this was some original hand sketch that I did on the left. We gave this to the engineer and just showed him how it was going to work. So I know it's kind of crude, but everybody who does engineering always sketches. So, and this is what was quick. So we showed them how that pour strip through their typical detail would actually be on the left-hand side on this picture. And we just extend the PT, we would install the couplers, and bam, we could take care of that gap. On the right-hand side, this particular engineer wanted to redo the detail a little bit and make a few modifications, which, we were okay with, the contractor's okay with, and, we were just happy that, we had actually talked to this engineer a few months before, so they knew of our product, but we were happy that they were willing and how quick this went to actually just install it. But that's the beauty of this, our product, is that it can go in at any time. The lockable dowel system, whatever you're using, if it's being proposed, needs to be designed in on the front end because of a lot of the things that Jason was describing earlier. So here's a few photos. On the left, this is it. I mean, so these guys, we were out there on this day with everybody, and it was super fun because they were excited because it was a new product. It was the first time they were, our really first one going in, besides what we did on that Hard Rock project years ago. So everybody's excited. They had to torque the bars. The threaded bar gets torqued in at about 130 foot-pounds, and then they install them. On the right-hand side, we're showing you there's a deep slab, 24 inches, and then most of that podium slab was 12 inches. So this was even a little different than, we didn't design the coupler to, support 24-inch slabs, but hey, it can actually, if you need rebar that has to be coupled through something, it doesn't really matter how thick a slab is. So here's a few more photos. This on the left showing, the coupler layout and all the PT and the rebar in the middle, same thing, a little close up. And on the right-hand side, it's really a shot at the couplers and how our first version of the couplers were installed. So we have a little piece on top that's a piece of wood that was holding our grout tubes back to the form, so nothing was loose. I mean, contractors don't like things loose in a form. So, and if you notice that silver pipe in the back, that's actually placing the coupler through the form in the right vertical and horizontal location. So I want you to look at this because we're going to talk a little bit later. My dad will jump in and tell you how we've modified the new coupler. And they haven't been engineering modifications because, you know, as structural engineers, we held the engineering paramount. What we've modified are the coupler for installation, learning from the guys in the field or gals in the field who've installed it and trying to make things easier and help even save more time and money. So, and this is what you get. On the left-hand side, that's our pour strip. And that gap is actually really small because they didn't pour that other slab until a little, you know, maybe a month or two later. So all that shrinkage and compression, all that on the right-hand side was because you're going to get it from both sides. But one side had a chance to do all that, and then months later, the other one went. So it wasn't that big of a gap. But this is the beauty of it, because that's another pour strip on the right in the same project months later, okay? So you can see this picture tells a huge story, all right? I mean, you can see it on the left, what you get, and on the right, same project. So this was easy for us to walk around this job site, talk to the general contractor, talk to our concrete contractor, and just show them what we can do. And they were just happy, super happy about everything. This next case study is a little bit different and a little bit, it was set up more for our typical layout because it had wood on top of the podium level, but we had a couple levels of PT below, which the slabs are similar to what we'd see in a hotel or an office, like an 8.5 inch slab. So this is a hotel down in Rochester, Minnesota. And we were able to work early with the engineer on this project. And actually, because of our PT and our concrete, all this experience and expertise we have, we helped them with some of their PT design and just getting the pour strip in the right location, getting certain things going so that it made things easier for the contractor. Basic layout here, floor plate. And as you can see in the red are the pour strips that were originally designed. So we had this layout to work with. And as you see, Jason was talking earlier about stiff elements. If you notice these, try to do this here, these cores here, there's a core right there, stiff element. There's a stiff element right there, that dark square. These are cores, stairs, and elevators. Another one right down there. So the concrete wants to shrink to those places, obviously. And that's why we need these strips. So moving along in this work we did, the original closure strip is on the left, and this was 45 days. Okay, we had mentioned earlier 28, 120 people, different requirements. This one was 45 days. We proposed the detail on the right, and we basically coupled the rebar that we needed for moment, shear, and all the cord steel and the continuity, and the engineer was happy with how load distribution was happening. It worked out well, and they approved everything through here. So beyond the engineering help we give you during your submittal and working with you and the EOR on the project and the design team, you know, we also provide layout drawings and shop drawings for approval. And so this is an example of this hotel where we provided a layout for placement, and you can actually see where every coupler is going. So with an elevation and all the distances and everything. So, and then we would go out. We have been on site several times on this project, and we help with field issues, we help everything. But actually, once these guys and gals did one or two of these, I mean, it was super easy. And the feedback from the field was, wow, you're making our life so much easier. So the learning curve is quite small, actually, short. So this is this particular project again. On the left-hand side, we have install and pour one. And we are still using the old coupler, and we have the wood on top, we have the steel pipe in the back, basically helping it be placed. On the right-hand side is, obviously you see we're pouring concrete, and this, you have shear keys in there, and we have the bar. I'm gonna try to at least highlight this in there. Can I zoom it in? Right there. So that highlight and magnified, that is a loose bar that is installed on the other side of the coupler, okay? And one other thing that we do on the edge during the installation process is we spray on a debonding agent to the surface of the first pour, so that we don't have it. It's amazing how well concrete sticks to itself through, you know, what we found. So this is a key part, because then it allows for this movement really to happen, and the bar to shrink and move with the slab. So moving on to some finish.
Yeah.
What this looks like. So on the far left, this was still during construction, and look at all, this was a particular challenging site in Rochester near the Mayo Clinic, and because it was more urban, I mean, it was like urban sheet pile, everything, you know, and they lay down space was a premium. So for them to even have access to this right now during construction was a huge benefit. And in the middle here is a picture of the joint being grouted, or has been grouted, and the couplers have been grouted. So this is more of a finish type look. But you know, I think this was maybe at the parking garage, and this will get a traffic coating over it, which is another benefit. You only need a small little traffic coating over a small one little gap, instead of two over a 4 or 6 foot wide gap, you know. And on the far right, this is a picture of the underside of the top podium slab. And as you know, this is clearly showing you how beneficial not having a 4 to 8 foot wide gap in your slab is to other trades, all right? This work would not have been able to be complete at this point in time if there was a big hole in the slab and all the formwork left in place. It's a clear example of what our stuff does and how it really is beneficial. So one last thing, and this is something that we're currently working on, and this is not post-tension related. So again, I think my dad developed this with all of his PT and all of our company's PT experience, but we are starting to see a need in even reinforced concrete construction. And so this system is a concrete beam and joist system. And they want to get rid of the pour strips. I mean, the general contractor right now is pushing for this. And, you know, I think the general contractor actually, we think that they and the owner have probably the biggest benefit of this, even though right now we're primarily selling to concrete suppliers. But selling it to an owner or a general contractor, where we actually see value in time and potential savings, like I just mentioned, on traffic coatings, or you know, other auxiliary pieces, your other trades getting in there early. I mean, that is just huge. And taking the pour strip off the critical path. I mean, gone. You guys don't have to worry about the pour strip being off the critical path. Engineers, you don't have to worry about the contractor complaining to you about how fast they can close up the strip, you know, because everybody puts 45 days or 60 days or 120, but you know it's not going to be that. They're going to come back and be like, hey, can you close that up in like 2 weeks? You know, I've heard of some stories recently on some reputable people and some nice hotel projects where they closed up in like 3 days. Slab crack, you know? So back to this though. So we have, on the left is a floor plate, on the right was a shop drawing that we submitted. So so the joist system and the slab is on the top here. Let's see, up here.
Double click it.
Is it double click? Yeah.
Double click it.
Up here.
Yeah, there you go.
Yeah, up there. Let's see. I'll do more. Okay, yeah. And then I just want to zoom in on the beam a little bit here because, ooh, jeepers.
Go
Let
back.
me go back here a second.
There you go.
Because this was something that we explored and detailed, and because this beam had is a very significantly loaded member, we have couplers that were going on both sides of the pour. So originally we designed this to really have it go on the first pour, but it could go on the second pour. But on this one, we're actually putting them in both so we could fit everything in together. And so this is being submitted right now, and we're waiting for some feedback. But we had some initial discussion with the contractor, the engineer of record, to get everybody comfortable. And so this is a market, if you're involved in non-PT reinforced concrete, that would be of interest to you.
Mid-construction.
Yeah, in mid-construction.
Yeah, on the third.
Yeah, and it's during construction again.
Yeah.
So anyway,
Yeah, anyway.
we're going to move on to talk a little bit about just a few developments that we've had since, and I'll play this,
Yep.
since some of these first installs and how we modified the coupler.
And if you look at the ICC ES report, it has the newest coupler in it actually. And these were basically form placers that we call them, where you can nail these to or screw them to the form, and then you can put the coupler directly to it. And you'll see as we move along here, I think we're going.
Yeah. Oh,
Okay.
Is it going?
Oh, just hit play.
Oh, play. Okay, sorry.
Oh,
Yeah. And so we can fit that on. There's also some new seals for the coupler to go against the.
There you go.
There we go. And the threaded couplers, we've gone to plastic pipes now because the contractors have found they'd rather cut them off than try to grease them and remove them. And that's a little tricky process kind of to get them at the right time. And so this, and then the screws in the back of the ears on the back of the coupler, you can see that. So they can just screw them into the form then positioned by that form placer. And so now we don't really need the boards on top anymore to hold those. They're a Schedule 40 pipe, so they're pretty stiff. And so this process, we've just found this from the contractors, what they like to do for these installs. And we've also found a solution, I will go to that, on also our V-joint. We'll probably get to it here, but we found something from a control joint in sheetrock. A good friend of mine with Perini actually told that to me while I was discussing with him. And we just got some samples in today, in fact, and it looks perfect. So we don't have to do the ethafoam rod or ever have to, okay, we'll kind of get on to, here's cutting some of these things off. We do mock-ups of everything. Thanks to a local cement supplier here, concrete supplier, Semstone, has allowed us to use part of their lab for some trials and things like that on many things. So anyway, so we try these things, and this is there's a new grouting pump here too, a hand pump we found to really clean things up. And you can, and if you like to keep the joint on top really clean, there can be like a masking tape type thing or whatever, duct tape, like you'd mask painting and such. We used to use the funnel for gravity feed, but these pumps work much better for us. And this is the sheetrock. It's sort of upside down, you know, how we would use it, but that's what we'll intend to use instead of the backer rod. That has to be installed after the fact, and when it's 15 or 20 feet in the air, it's kind of difficult. So these are some of the improvements that we're making, and we're continuing to look at better ways to do things and feedback, but we're getting it pretty well done right now. So I think I'll give it back to Jared, our moderator, and
So yeah, I think we did pretty good on time. We have a lot of room for questions, but one thing we're just going to mention is that what we include with our PS0 is the PS0 coupler itself. These pipes, the grout tube pipes, the grout tubes here that are threaded, the form placer, and we have a debonding agent, sprayer,
and the debonding
and the debonding
debonding
agent,
Grout mixer.
and grout mixer. I know, right? We got stuff
And
here.
then,
Well, that's just a pipe.
yeah, no,
we need
so
to
if you got thicker slabs, you know, you can make these as thick as you want.
Yeah.
This is what we went to for the girders.
And there's a grout gun here. That's just getting into kind of the particulars. But thank you for listening to us talk about this product, which you can obviously see that we're really excited about and passionate about. We're going to try to go to some questions here and see if we can get through some of these, because we have, and I'm going to take the presentation off.
Yep.
So you're just going to see us.
Uh-oh. There we go.
So
Okay.
let's go back to the beginning and just kind of go. So, oh, this is a question about the grout. So what is
Good question.
preferred, what is the
Good
preferred
question.
brand manufacturer for the cementitious grout that works best to flow? Okay, you guys. Yeah, you wanna go?
We work closely, well, Jay, you worked with the BAS, they're local here.
Started with Master Builders.
Yes,
way
Master
back.
Builders. Yeah, and we use their 885 grout. So if you look at our ICC ESR approval, it includes that 885 grout. We like it because we tested them at actually 8,000 PSI. Okay, with Jenny in Chicago about a little over a year ago. And, but we like it because it ultimately will reach a 12 to 15,000 PSI. So the 8 was a conservative.
But we are testing other grouts right now on our lab in the basement. I don't know how many buckets of cubes we have to go get broken.
So good question here,
Very good
because this
shape.
comes up about basically reshoring. And so the question is, how is the vertical shear transfer through the slab self-weight after forms are stripped and construction joint loading prior to grouting? So I'll answer that, because we've been, it's one that right now our position is that you're going to reshore just like you would a traditional pour strip, however that would need reshoring. So yeah, like however the EOR specified. So most of the time we see this at a third point off the columns, or we see this in the middle of the slab at the pour strip itself. So usually off of the third point near the column, that small cantilever of the column can support the weight of the slab, can so sometimes support the weight of the strap, the dead load of the slab. So our coupler works no different either way. You know, it can support that weight. It can also have to be, you know, would have to be reshored in, you know, if it was in the middle of the slab. So it's no different than you would find on your typical pour strips on how they're designed.
And typically on the cantilevers in the middle, our designs usually include enough PT to hold the cantilever.
To hold the cantilever piece.
When we're the EOR.
When we're the OR. Other cases would be, you could always put a small 2-foot piece of form in or something and put reshoring in right away to strip the forms. There's a lot of options there. Yeah.
Another question here. Have you seen this? Have you used this in like a Class A office space? So we have not done an office building yet, but any post-tension structure
Or
mildly reinforced structure could definitely, where you have a pour strip, our product could be used. You might, a lot of architects these days are wanting exposed floor finishes. So we would have to, you know, work with how that might look if that's a finished concrete look that you're going for. Or most structures getting floor coverings, whether it's carpet, tile, or something like that.
You're going to have one joint instead of two.
But yeah.
I mean, in your Class A office space to deal with, if you're looking for concrete floors. So there'll be one joint instead of the two, and you will have, you know, 2 more continuous looking slabs than, you know, having a 4-foot, 8-foot gap in there where your typical pour strip that may be discontinuous in color, you know.
Another question here. Historically, which sub has handled the grouting, caulking, the soffits? You want to answer? I mean,
Well, the soffits or the forming,
Yeah.
typically, I think on both jobs it was Seco.
No,
Was
the forming sub.
Forming sub.
Yeah.
For the soffits?
handled the grouting.
Yeah, but the grouting
No, the grouting
was
yeah.
done by the subs.
Concrete sub.
Concrete sub,
The concrete sub did the grouting.
yes.
And honest,
Has been.
if there's any concrete suppliers out there on the webinar, which I'm sure there are,
Contractors.
contractors, sorry. You can imagine your crew you need to pour back the pour strip versus, I mean, 2 guys or gals to grout and, you know, pour back the gap. It's, yeah, a lot less work on the back end.
Yeah, I think both of those, the 2 of the contractors, at least that we've been having listened to and that, say that's their most expensive concrete on the job. Because you need to bring a pump back, you need to bring often you need to bring a crew of 4 to 6 people back, and they need to take all day because they need to concrete finish it, which in our case was finished during, the time of the original pour when the whole crew was there.
So a good question here about the PS0 being used in stadiums or on radiuses. So I would just go back to, we haven't done any stadium work yet with the PS0. I'm sure it's coming, but we did the Hard Rock. So the project that the coupler was born out of was a project we talked about earlier, and we didn't get into it, but we actually took a bolted type coupler from the precast industry, and we're able to get that 8-foot wide pour strip down to about 1 foot on that project. But we had to get only 1 foot because we had to get in there to crank the bolts down. So yes, the very first time we did this was actually on a radius in that hotel that we showed you earlier. And I mean, we don't see any issues with radius.
And on that particular one, we also had our own person there as a special inspector. Yeah, that was helpful.
Do you have any solutions in development or minimizing the appearance of grout tube circles on the top of the slab that are going to be polished? Okay, so this goes back to the question about finished floors. So we don't have a great solution yet for that, but I think it's all on the finishing. I think we're minimizing. We have these holes that we need, but we're minimizing the appearance as much as possible. I think it's more on how you actually do the final finish of that. So as you saw, I think in one of the last slides, one of them was pretty sloppy, that was going to get a floor finish anyway and topping. But the other side was an exposed, a little bit of exposed slab in the parking garage, and that was much cleaner. So it's kind of a little bit of a learning curve, but I think that's something we're going to work with people on and figure out eventually. Is the vertical joint fire rated? I'm gonna let Jason take this.
It doesn't matter. Yeah.
Go ahead.
Yes, it's fire rated. Same fire rating as steel and concrete. 3/4 cover, typically. It's grout. It's a cementitious grout. It's no epoxies. Yep.
Yeah. Do they come epoxy coated? Good question, Jason. To take it, we got a current project we're looking at actually right now. We're doing. We're installing in a month or two here.
Yeah, and so there's a couple ways to look at this. One of the ways you can look at it is typically we're going to install these in the bottom of the slab where we're going to have the bars. And so is it required? That's one way to look at it. Another way to look at it is, yes, we can have them grouted, epoxy. Adam Simet with Simcoat right down the road, they make epoxy coated rebar. They have the facilities to do it, and he's already agreed to do it. The other side to look at it is, Katie out there have been involved in post-tension repairs, and what we always do is in the field we just paint them with a similar type coating. But they generally, it's a better coating, like dog bone, like an intermittent stressing block, internal stressing block. We usually paint those in the field and then pour it back up. Performance is actually a little better because they don't get nicked because they're in place.
And our ICC does not address the green bars, so to speak, or whatever, but we have tested a series of them with Element in town here. And we've never had a break. The bars always break, no matter what. There's no grout breaks or anything like that.
All right.
So another question here. After the shrinkage occurs, do you ever have to go back and fire caulk? Well, I think we basically answered that question with, the joint itself is rated with the cementitious grout.
Yep. And the steel. Yeah.
Well, yeah. It still has the cover. So, and it's covered. Yep. Another question here. How do we take big cord bars, number 10s, 11s, through the joint?
There's two couple ways to look at that. I mean, we just did that with the girders. Go ahead.
We kind of did that. Right now, we're also starting a testing process for number 7 bars. This coupler will manage either a 6 or a 7. Yep. Typically, we have a number 6. So we need more of them or whatever to match those. If you had some really big bars, we have not seen that much, and I have not seen too many 10s or 11s in cord steel diaphragms, usually because the D is so big that we don't often need bars that large, but we can match the area
Yeah, we can match
and
the area
achieve
easily
that.
for you. Yeah.
So I was going to add something to that actually, because if we were able to work with the engineer record and figure out what those forces are, you can always add couplers and add more steel depending on how many number 10s you have, and we could substitute some different size bars to get the same strength requirement.
Through that section.
Yeah,
Yeah.
where we need it.
Yep.
Let's see here. There was a question. You mentioned the shear transfer during construction that reshoring may be required joint. In your projects where you design for third span cantilever to support the other slab and no reshoring is used, are there any mechanical attachments? So when to answer this question, the question being answered is when the cantilever slab has been designed to take support the slab coming from the other side, is there anything else you need in shear keys you recommend? So I think we as structural engineers like shear keys, and so a lot of the projects that we have been working on there do have shear keys. So a shear key, if the cantilever is designed to take that shear, then a simple shear key is gonna be fine. The other thing that we have seen is that our rebar, because of the way it fits in and everything, it is also helping hold up the slab itself, and there's not a lot of movement is what we can tell. So there's probably more to come on that in the future. But right now, our position is really that if the PT was designed a certain way with the standard pore strip, that you would really reshore and shore the same way you would with ours. You could just get rid of all that additional formwork and the big gap.
You can turn it around and show the gap.
Of what?
Of the back of the coupler. Yeah. So.
Yeah, so this is the other side of the coupler, if you guys can see.
This is a
There you
little
go.
different than your standard Linton or Dayton Superior coupler.
Yeah.
It's really set up for precast, okay?
Yeah.
This one is a little different, and it has a hole that will just accommodate a number 7.
I'm just gonna do this right
Yeah.
here. So we have the threaded bar goes in this
Pour
side
one.
here, pour one, with your formwork back here, and then
That's it right there.
pour two is a loose bar that goes in, and actually there's a seat inside, so you know when it seats inside the coupler.
Yeah.
So, and then after when that shrinkage is occurring, it pulls out slightly, and
And there's very little play. Yeah.
we're getting close here to the end, and we got to want to be respectful of everybody's time, but we'll take one more question here. Someone's asking about contact info, so we'll get some contact info out there, having some trouble finding us, but hope we don't want that to be the case. We'll get in touch with you, Josh. And we're also going to send something out tomorrow that's going to be a link to this presentation and some additional info. But let me see.
The one thing I had, if you were logged in anonymous and would like any information, you can just reach out anytime or let us know on the attendee list.
Yeah.
Somehow.
Or you can always reach us at the Rigsted.com too.
Yep.
We all have emails, JG Rigsted and JM Rigsted and G Rigsted at Rigsted.com, which is REIGSCAD.
So maybe one or two more questions here, because this is good. This comes up. Can you cut the grout tubes off at the slab elevation prior
Yes.
to the pour? So yeah, so the finishing guys would love this, and so you can do that. We haven't toyed with that idea, but you just got to make sure you get your elevations done properly. And the thing is, on one of our jobs we've done is they didn't really worry too much about the tops of where the top was. They kind of just finished over top of it, and then they thought if we could find one little concrete got on top of it, if they could find one, they could find the others and just chip them out a little bit.
Yeah.
So if you want back to that question about a nicer finish, your finisher could finish over top of the caps and then just knock some of that concrete out later and then re-pour, and it could be a much cleaner way of doing it there.
Yep.
I think we'll take maybe one more question. How much lag between placement and grouting the tubes? Is there potential for this? And there's two questions.
Yep.
And is there potential for this in post-tension beams?
Yeah. Oh,
You
go
guys can
ahead.
take the question.
No, you could do the same way that we're
Right.
managing things in the joist system.
Yep,
With the
same thing.
beams. So the answer is yes, through the beams, you could do that. And what was the other question?
It was the leg between driving the tubes. And
whatever
that's
the EOR
That's
was.
up to the EOR.
Yep.
And one of our goals here is to take pressure off the EOR, because normally it isn't getting in the general's way not to grout them, because maybe even if there's a few shore posts, mega shores or whatever, 8 feet apart downstairs or 12 feet apart, this really doesn't interrupt his construction very much. So the pressure would be off. But if someone wants, 28 days, 20 days,
Go ahead.
that's an EOR call on when you would pour back a pour strip.
Actually,
Yeah.
if everybody's got time, we did get a few more chat or questions on the QA, and this comes up from engineers. So I'm sure this was an engineer who asked about this. So the diameter of the coupler looks a lot bigger than the bar. Won't this reduce the effective D, which is essentially the moment, the capacity of the slab or the beam? So the answer is yes. But with a 3/4 inch cover on the coupler, we're losing and this came up on the projects that we discussed earlier, we're losing very little D. And depending on where the pour strip is located, your moment forces may or may not be that large, or you might not mind losing a little D depending on how tight your design is. Or we have to just put a couple more couplers in.
Yes.
And just add a few more pieces of rebar through there. So all solutions, that we've used before, and we can, definitely handle those. One question: can the inserted bar develop low tension? Great question.
Go ahead.
It's an engineering type question. So what we have right now, on one of our first installs, we were actually just using the rebar that was already going to be there. So we had these longer bars that were, one was threaded and then one was inserted. What we found off that job is that it's a lot easier to work with smaller pieces. Okay, so right now we have a 4-foot threaded bar, which the lap length is 48 inches, and 48 inches laps with number 4s, number 5s, easy to get full capacity, 6s even. So, and then on the other side, the loose bar, it's actually, we just make it a 5-foot bar, because this is about 8-9 inches long, the coupler itself. So that extra foot, when it pulls out, you still develop the full tension capacity in the bar. Anything else here? We're gonna hit.
You can use the full bar.
Yeah.
It's up to them.
But you can use the full bar. We were telling contractors sometimes that there's we work with the rebar suppliers to work out what's best for the project. So, I guess we're just over 2 o'clock. I think we're gonna wrap up. Like I said earlier, we're gonna send out another message tomorrow that's gonna basically give you access to the presentation. We'll have more info about getting in touch with us. We want to thank everybody for coming and your interest in our product. Like we said earlier, we are, structural engineers who are really involved in just wanting to push this construction industry, further and make it better.
Yep.
And safer.
And safer. And we're just trying to use our knowledge to, make things better for everybody. So thank you again. And we're going to be doing some future webinars coming up here. Based on questions and based on different topics. Today was an overview and showed you basically all the high points of everything, but I think we're going to have some more specific engineering related webinars coming up, maybe more specific install webinars coming up. And we got a cool animation video coming out in a couple weeks that we'll share with everybody. So stay tuned for that.
And if anybody wants, a more tailored webinar, just let us know,
Yeah, Jason and I primarily we've been running around the country before all this COVID virus stuff. So now we're been home, but we can definitely tailor things to engineering firms. We've done a lot of those, or contractors, formwork guys, all kinds.
Whatever you want.
Yeah, whatever, and speak specifically on different topics. So more than willing to do that. Just reach out. We'd be happy to.
And the easiest way to have us look at something is just send some plans. We could send you back a simple markup on what it would look like. you know?
Yeah, what the changes are, similar to some of the documents we showed earlier in those case
Yeah.
studies, what it would take. Because what we like to do is we like to tell the contractors and GCs what the differences are, and we're not trying to hide anything here.
No.
We think we have a great product that does everything start to finish, engineering through install
No.
and finishing. We just want everybody to know what's involved and all the pieces, and it's still making sense, okay? Because on one of the first ones we did up here, the savings in the formwork from Seco paid for our couplers.
Yeah.
So the goal too, I think, by my dad was to really develop a product that wasn't going to cost any more than you're already spending on a traditional core strip.
And
That's
we've
cool.
achieved that.
And I
Easily.
think for the engineers out there, you know, if you even throw some options on your, you know, do your traditional pour strip, throw some options to alert your potential contractors or whatever, then they can look and sort it out for themselves.
Okay, well, we could probably sit here and talk all day about
Yeah.
this. So
I know we could.
thank you for your time again. Look for an email tomorrow with a link to the webinar. We really appreciate you spending some time with us, and have a safe and happy 4th of July. And
And yeah, share this with anybody you want once you get recorded. Anything you need, we'll be here for you.
Thank you.
All right, thank you guys.
thank you.
And